Welcome back to Step Electrical Friends. Today we are going to solve a numerical problems related to Kirchhoff's law. This is our second problem related to Kirchhoff's law. So here the question is, we have to apply KVL and KCL to determine the current IL through the 1 ohm resistor in the network shown below. Let's see the figure. This is the figure for this numerical. Here IL current is unknown and we have to find out IL current, and this IL current passes through this 1 ohm. To solve this numerical we have two approaches. So let's see the first approach. In the first approach we have assumed that I1 is the current which flow through 2 ohm resistor. We are starting from here. I2 is a current flowing through AC branch. Both comes together and meet at point at junction A. Then the total current flowing through this AB branch is I1 plus I2. And now at junction B, I1 plus I2 is a current flowing through this AB branch. Through the branch DHB, current I3 flows, which enters the junction B. Both I1 plus I2 and I3 are the currents which enters the junction B. So the total currents which leaves this junction is I1 plus I2 plus I3. Here there is no element, and finally IL is equal to I1 plus I2 plus I3. Required current, that is IL, is I1 plus I2 plus I3, and we have to do nothing. We have to assume one another direction for the moment of writing KVL. Here are 3 loops, 1 loop, 2 loop and 3 loop. There are 3 loops, and we will easily find this unknown current IL. So let's see the next approach. This is our second approach. In both of these approach, the number of loops are same, but in this first approach we have assumed I1 and I2 is a current which enters the junction A. Okay, but in second, as we start from here, through branch DHB, I1 current passes and enters the junction B. At B, IL leaves the junction, where so that the total current which will flow through this BA branch is I1 minus IL. And now again here we assume C through branch CA, I2 current flows which enters the junction A. Through branch AGFC, I2 plus I1 minus IL current which will flow. Once again I want to revise this sign convention. If we move from negative terminal of the battery to the positive terminal of the battery, then the potential drop across the battery is positive. And for in case of resistor, if the direction of assumed current and the direction of movement for writing KVL both are in opposite direction, then the potential drop across this resistor will be positive. Here we have three unknown currents, I1, I2 and IL. So here we have assumed clockwise direction for each direction of movement for writing KVL in all these loops. First of all, we will write KVL equation for this first loop. Okay, so let's write the KVL equation for this loop. Applying KVL in loop A, C, F, G, A. Here 8 volt. This one is positive. Why? Because we are moving from negative to positive terminal. That's why it is positive. The potential drop across this resistor, the direction of this assumed current is in anti-clockwise direction, but the direction of movement for writing KVL is in clockwise direction. Since both directions are opposite, that's why the potential drop is here positive. So the potential drop across this 2 ohm resistor is 2 into I1 minus IL plus I2. This is the total current we have already calculated here. So I2 plus I1 minus IL is the total current flowing through this 2 ohm resistor. The potential drop across this 4 ohm resistor is 4 into I2. Why? Because the current flowing through this 4 ohm resistor is I2. The direction of assumed current is in anti-clockwise direction, and the direction of movement for writing KVL is in clockwise direction. Again here both directions are opposite, that's why it is positive. And this is our first equation. Okay, Applying KVL in loop A, B, H, D, C, A, 2 into I1 minus IL. Again here this one is positive. Why? Here this one is 2 ohm resistor, and the current is, the direction of this current and the direction of movement both are in opposite direction. That's why it is positive. 2I1. Again here the direction of movement is in clockwise direction and the I1 current is flowing in anti-clockwise direction. That's why again here it is positive. Both directions are opposite. That's why it is positive. And now here this 4 volt is negative. Why? Because we are moving from this positive terminal to negative terminal. We are moving from positive to negative. That's why positive to negative, opposite. That's why it is negative. Here the direction of current I2 is clockwise direction and the direction of movement is also in clockwise direction. That's why it is minus 4 into I2. And on simplifying we get 4I1 minus 4I2 minus 2IL is equal to 4. Applying KVL in loop B, E, D, H, B, we will start from here. IL is the current flowing in clockwise direction and the direction of movement for writing KVL is also in clockwise direction. So it is minus 1 into IL. And the potential drop across this battery is, we are moving from negative to positive terminal. That's why it is positive. Negative to positive. Negative to positive is positive. So the potential drop is positive. And here the direction of current I1 is in clockwise direction. And the direction of movement is also in clockwise direction. That's why it is negative. The summation is equal to 0. So on solving we will get 2I1 plus IL is equal to 4. So these all are the 3 equations we obtained from with the help of these 3 loops. So on solving these 3 equations we get I1 is equal to 1 ampere, I2 equals minus 1 ampere and IL equals 2 ampere. In question we are asked to find IL and this IL is equal to 2 ampere. One thing, once again, here I2 is negative. This I2 is not the current which enters the junction, it leaves the junction. I have left the final diagram for you. Just change the direction of this current I2. This is all about the numerical problems related to KVL and KCL, that is Kirchhoff's law. Thanks for your patience and attention. Hope see you in next video.